All right, we're going to go a little more in depth with our KC6 notes here. This is really, we're going to go a little more in depth with volume so that we can do that advanced task on the test. All right, so the first thing we're going to look at is the volume of a sphere. Okay, so the volume of a sphere is 4/3 pi r cubed. So this is just another volume formula that we can use. Okay. So again, I have 4/3 pi r cubed. Okay. So my r, right, just like before, it's half the circle. So for this case, it's 12. And then again, I'm just going to type that in my calculator. I have 4 divided by 3 times 12 to the third. And I get 2,304 pi. And this is going to be centimeters. It's still just volume, so it's cubed. The second thing we have here is a hemisphere, by the volume of a hemisphere, and that's just half of a sphere. Okay, so for the volume of a hemisphere, we're going to do 1/2 times the volume of our sphere, 4/3 times pi r cubed. Okay, so we have 1/2 times 4/3 pi. And this is 9 cubed. So again, typing that into my calculator, I have 1/2 times 4 divided by 3 times 9 to the third. And we get 486 pi. And this is just some unknown unit, so units cubed. Okay, so again, spheres is just another one of our shapes that we can find the volume of, no different than all the other volume stuff we did. Okay, the next thing we're going to look at for our kind of extending what we know about volume is, what if I know the volume? Can I find something else? Okay. So this says, ignore these boxes. I meant to get rid of them, and I didn't. So a cylinder has a volume of 100 pi inches cubed and a radius of 5. So I'm just going to draw my cylinder really quick. Okay. So the radius is 5, and the inside volume is 100 inches cubed. What is the height? So I don't know what my height is. Okay. So I'm going to start this the same way. I'm going to start by doing the volume of my cylinder, pi r squared times height. And then I'm going to plug everything in. So I know my volume, right? Volume is 100 pi equals pi times my r is 5 squared times my height. Okay. Once you have everything plugged in, all I'm doing is solving for my variable. Okay. The first thing I'm going to do is simplify anything, so I can have that 100 pi equals, I can square this 5, right? 5 squared is 25 pi times h. Okay. Now I'm just getting my variable by itself. Right now, h has a 25 pi next to it, so I'm going to divide by 25 pi. When you have pi over pi, right, that crosses out just like anything would cancel out. So really I have my height here is 100 divided by 25. And my height is 4. 4 inches. All right, let's look at our second example. A cone has a volume of 96 pi meters cubed and a height of 8 meters. Okay, so my cone, remember, meets at a point. I know its height is 8. So I want to solve for the radius. Okay, so the volume of a cone is 1/3 pi r squared times height. So volume 96 pi equals 1/3 pi times r squared times 8. Okay. So again, looking at this side first, what can I simplify? Since it's all multiplication, I'm going to multiply my two numbers together. I have 96 pi equals 8/3, right? 1/3 times 8 is 8/3 pi times r squared. Again, I want to get my variable by itself, so I'm going to divide both sides by 8/3 pi. So then, again, the pi's here, these cancel out, pi's cancel out. 96 divided by 8/3 equals 36. Okay. So 36 equals r squared. The last thing I have to do, this is going all the way back to our key concept 2, I believe, in first semester. I have to take the square roots of both sides, right? That will get rid of the squared. The square root of 36 is 6. This is meters. Okay, so my radius is 6 meters. Okay, so these types of problems are really just solving for your variable when it comes down to it. It's just an equation. Okay. All right, looking at example 5. Farmer Brown stores his grain in the building on the right. Use the picture to answer the following questions. How much grain can the building hold? Okay. Well, how much grain can it hold is just a question of volume. So I'm going to start by finding the volume of the cone. Okay. So 1/3 times pi r squared times height. That's a 1. Times pi times r is, right, 5 is r. Not a great r. R. 13 is h, right? So 1/3 times pi times 5 squared times 13. So I have 1 divided by 3, which is 5 squared. We have 108.33 pi, and this is meters cubed. Right, so that's for my cone. Then, right, we have this little baby cylinder on the bottom. The volume of the cylinder is just pi r squared times h. So that's pi times 5 squared times 8 times, ignore that, times 2, right, is my height here. My radius is still the same. 5 squared is 25 times 2 is 50 pi. Again, always feel free to use a calculator. Okay. So then for my total volume, all I'm doing is adding. Right, 108.33 plus 50 pi is going to be 158.33 pi meters cubed. Okay? So that is how much grain the building can hold. Looking at our next example, how much grain is in the building when it is half full? Well, if it's half full, I'm just going to do 1/2 times 158.33 pi, right? And I have 79 is about 79.65. 165 pi. Okay. Meters cubed. Okay. So with that one, I'm just seeing what half of that original volume is. All right, and finally, letter C, our last question here. How high will the grain go in the building when it is half full? Okay. Well, the first thing I want to look at is my picture. I want to know how high is this grain going to go up. The first thing I have is this cylinder. Ah. Is this cylinder is this amount of grain when it's half full going to fill up my cylinder? The answer is yes. All right, I will fill up my entire cylinder. So I'm going to do 79.165 pi minus the, sorry, let's bring this down a little bit, minus the 50 pi that fills up my cylinder. And I'm left with 29.165 pi, that much grain, meters cubed of grain. So now I want to see how high is it going to go up in my cone. Okay, so for my cone, I now know I have a volume of 29.165 pi equals pi times my radius is still 5, so 5 squared. I just want to know what my height is going to be. Okay? So then I have 29.165 pi times 25 pi times h, right? 5 squared is 25. Then this should be an equal sign. Then to solve for h, I'm going to divide by 25 pi. Okay. H equals, pi's cancel out, 29.165. Oh my gosh, I can't type today. 29.165 divided by 25. 1.1 meters. Okay. So, looking at this, my total height at the end, I'm going to fill up all 2 meters. And then I'm going to fill up another 1.166 meters. Okay? So how tall in total is my grain going to go? Right? It's going to go 2 meters and then another 1.166 meters. So I'm going to add those 2 numbers together. So my 2 meters plus my 1.166 meters. Alright, when I add these together, I get 3.166 meters tall. Okay. So, something to be careful with, right? Major mistakes. If I look at how tall this building is in total, it's 2 meters here and 13 meters here. It's a total of 15 meters. A lot of students want to say if it's 15 meters tall, when it's half full, it's going to be half of 15 meters. But it's not, right? The base of this with this cylinder holds a lot more than this cone up here as it's getting smaller and smaller near the top. Okay, so make sure you are going through all those steps. All right, go ahead and get this activity, work on that, and then we'll take the advanced task of the test.